Hello, everyone. So, last episode, this is where we left off. We were making a size 8 nib, and we were getting ready to tip because we had shaped it, we had bent it, we had did all the prep work in order to start tipping it. And tipping it is become an easier job than it used to be. And before we go into it, I'll take you through kind of a history of how I learned to do the current tipping that I do. So when I started first making nibs, I started off using this system, which is simply my acetylene torch, my jeweler's torch on my jeweler's bench. Let me get back in place for you. And this works pretty good, but the problem is that it's not as accurate as you want it to be. The problem being that the tipping is a small ball, and we'll go over the tipping in a minute, but because it's a small ball and this is a direct flame heat source, it's very difficult to be accurate to place the tipping in the center of the triangular tip. And I worked with ways of trying to hold it and trying to keep it centered and things like that, but I can never just get it perfect every time, what I thought was perfect. So eventually I abandoned this method and I went to a different method. What you see before you now is a Sunstone Fusion welder. And it was my second method. And it worked kind of. And I spent a ton of money on this thing. These things are like 15 grand. I thought it was going to be the savior, the great idea. But it turns out that it's not that great. It's good for other applications, like if I want to tack two pieces together that are flat. But the problem is that I couldn't get the tipping at the edge of the nib like I wanted to. What I mean is when the nib is tipped, and here you see the ball. Let me see if you can get that clear. You want the ball to be on the edge. I was tipping this on the underside, and I thought it would work good, but it didn't. So how this worked was, obviously this was air actuated, and when your air compressor was on, it would come up like this. And I would stick the ball, the tipping ball, right here. And I'd place the nib down here. And once I got the nib over top the ball, I would hit the foot pedal and it would come down and a spark and it would weld. Now it would weld it every time. Like I said, the problem was it wasn't edge welding, and I had no way of doing it this way like the professionals do that have the expensive one, because the ball, I tried that a few times and the ball would just take off flying, because this actually goes a little bit quicker than the ones that you see at the professionals that use, and it's really a different system. So this turned out to be kind of a bust. So here we are at the current welder that I use. And actually, it was the welder that I originally used on a suggestion from Jim Crawford. And everybody knows Jim, who does a lot of the great stacking of nibs and things like that. He is really good with that. But on his urgency or his suggestion, I should get one of these because that's how he tips some of his stacked nibs. And I think a lot of other people use it too. But when I first started using it, I didn't completely know how to use it. And I'll show you why in my next video. And then we'll go over what makes this a great machine for doing this. All right? Here are some early nibs when I first started 3 years ago. This is, in fact, number one, and the one I want to talk about. Now, let me see if I can get that camera to hold straight. if you look at the tipping and you look how I did it, I actually did it with that welder. It's kind of hard to see. Let's see. Okay, now you can get a good view of it. Okay, so what is wrong with this? Well, for one thing, when I originally started using this, I just tipped the ball to the nib. What happened was it was either going to distort or thin the metal to the nib, and you can actually kind of see that where the tipping right here and the metal come together. You see a dip down in there. And what happens is when you force metal onto another metal by using a welder, you're going to thin out that area because what you're doing is spreading the metal from one place to another. And this was my very first successful nib. It worked. I actually used this nib. Used it. I don't use it anymore, but if I wanted to, I probably could make it work. So while we're on the subject of the shape, let's talk a little bit about why I changed shapes. One of the things that I wanted to do, even when I first started making nibs, was have more of a traditional vintage shape, like the old Schaefers or the old nibs from the past. And the reason for that is because I just like the way that they looked. I think when I first started making nibs, I'll be honest with you, I just wanted them to work and I wanted them to have some stiffness. And I thought by making this, like I called it the kite shape, and it's shaped like a kite a little bit, I thought I would get great stiffness, and I did. But also some people don't like a nail for a nib. And there is ways I can do to make my nibs either stiffer or softer. But I really like the shape, and with the help of Bonnie Doon Tools, we came up with a size 6 and a size 8 that really look good. And once you bend them and tip them and slit them, they have a very vintage look to them, and I really like that. Let's talk tipping. What is used to tip the nib? Now, believe it or not, there are about 2,000 tipping balls right here. It doesn't look like it, but let me tell you something. At 1.25 millimeters in diameter, it's not very big. And what I usually do is I usually transfer a little to this one right here and keep this one so if in case I drop it, I don't have tipping balls I can't find everywhere. So I usually work from this little jar, and you see there's about 7 or 8 of them in there, and I've been using this jar filled with about 20 at a time. So in case I do drop them, I'm only missing 20, and at the price what these things cost, I feel like I'm making the right decision. But back to the tipping. So tipping has to be a harder metal than what you're making the nib out of. Even harder than steel if you're making steel nibs, and even harder than titanium. What is tipping made of? Well, that's a good question. All those years you've been thinking that tipping is iridium. Maybe back in the old days it was, but not anymore. It hasn't been iridium for a very long time. The reason being is iridium is very difficult to get, very difficult to process, and very difficult to work with. Also, it's extremely expensive. Extremely expensive. I think it's more per ounce than gold. That's how expensive it is. And you see a lot of this iridium tipped, iridium tipped, iridium tipped. Well, that's not true. So what is this? This is made by a company called Harius, and I use the AM version, which is best for using with precious metals like gold and silver. And it can be used on steel, and it can be used on titanium. But it's a blend of metals to create a hard surface, but also create one that is corrosion resistant, and that once it's ground, it will glide. Also, it needs to be able to be welded to the precious metals or any other metal. So this tipping is a blend of, I think, 3 or 4 metals, but I'm pretty sure there's tungsten, osmium, and ruthenium, which are the major players in this tipping. There is no steel, there are no ferrous metals in here. Ferrous metals meaning that they are derived from iron. They're all more precious metals, and tungsten is actually the hardest metal on the earth. Most of what you see made out of tungsten is made from powdered form tungsten, and it's pressed and heated to very high temperatures so it will fuse together and bond together to make the metal one piece. And I think that's how these are actually made, but I'm not sure. They don't share the process with me. So how do I tip my nib? Well, it's actually very simple. I got these really inexpensive ceramic tweezers from, I think, Amazon. And I ground them down, and then I ground a small pocket on each end so it conforms to the ball. I used a high-speed rotary tool. And what I do is I go into the jar, and under microscope, I pluck one out, just like this. And it's not going to go anywhere. It's in there pretty good as long as I don't open the tweezers up because it's spring-loaded. So even with this video trying to show you, I lost one because I didn't do it under the microscope, and I tried to do it too fast, and bam, one went. But if I'm doing it the right way and under microscope, I can pick one up pretty easy, and it stays here and it's pretty well secure until I tip it onto the nib, and then I'm able to remove the tweezers. So like we discussed before, this is the Sunstone 100C, made by Sunstone, but they call it the Orion 100C micro arc welder, and it's capable of like 100 watts per second. I'm not going to go too much into the welding, but a lot of these welders are used by jewelers and model makers and, just people who like to weld small pieces together. They have different settings, and you're also able to update the software via the internet. And they're really cool. And if you go on YouTube, you'll see a lot of videos on how to use these things and how they work and what is what applications that they can be used for. But it's a really great tool. And this is how I personally now tip my nibs, and I found it to be very accurate with the new method that I'm using. Here we are at the welder. Okay, so under the microscope, I would be looking through the microscope, and I would find the center of this nib here. And then when I found the center and I had the two closely attached, using this tip, I would hit it once or push the foot pedal, and it would tack it. And that's what we'll do next, and I'll show you a video of that. All right? Stay tuned. All right, it might be hard for you guys to see, I'm not sure, but we're going to try to attempt this. I'm putting the nib on this side and the ball on this side so it'll be easier for you to see. But I come over here and I'm looking at my area and I'm seeing where I got the ball, and bam. All right, I'm holding this with my hand to show you as close as I can get it. But you see that weld on there? It's pretty good. I'm sorry for the shaky hand. I'm not as young as I used to be. But you also see that it's right in the middle. And let's say that it's just a tack weld. So let's just say that I didn't get it in the middle. I have two options. If it's not too far over, I can take a small plier, and I can kind of fiddle it, maybe get it pushed over a little. If it is too difficult to do that, you can actually break this tipping off really easy with a small plier and start over again. That's what the beauty of this method is. But as you can see, I've got most of the tipping ball at the underside, which is what I want. That's exactly how I want to start this. Now that the ball is tacked on and you see it's right there in front of the welder, what you see before you is a piece of wire. And this is the magic that makes the whole thing come to life. So prior to using this method, I had been researching how to do this differently and more accurately. And what I found was, even in the industrial welding, is when two pieces are welded together, they're not usually just butted up together. What usually happens is they create a 45-degree angle or an angle or a gap somehow, and then they weld metal into the area that's going to be welded. So it's like a third type of metal, usually using the same type of metal that they're using to weld to each other. And I don't want to get all convoluted and mixed up here, but basically what I'm doing is instead of thinning out this metal, I'm adding metal. I'm fortifying it. I'm creating a larger weld area and a surface area to be more structurally sound, if that makes sense. So it's pretty boring to watch. So what I'm going to do is I'm going to do it, and then I'm just going to show you the results. All right, here we are. As you see, there's a lot of extra metal there. And I'm trying to focus so you can get a good look at it. Now the ball is somewhere in there. But what you don't see is thin metal. What you see is added metal. And this is all the same material that's been added. It's not annealed because it was welded and not soldered. And the reason that I'm able to do this is because I'm able to, just like, let's say this was any kind of metal fabrication, I'm able to shape and sand and grind all of this down to be more smooth and to flow with the tipping into the nib while keeping it structurally way more sound, basically. And I'm going to do that next. But first, I'm going to show you the set of tools that I use to do all that. Before you, you're going to see a lot of hand bits or small bits that go into this Foredom handpiece, and they all have a use. But what I do now is starting off with a small ball burr, diamond ball burr. I start to do the initial shaping of the nib. Then I'll move to I forget the name of these, but they're made out of like silicone carbide or something, and that's even shapes the ball a little bit more, but with a less rough texture. And from there, I move to a series of, and these are really neat, and you can get these off of Rio Grande and a couple of other places. They start from very coarse and they go all the way to fine, and they are made of also, I think, rubber mixed with some grit, I think silicone carbide, and they start to smooth out the nib all the way to fine, where I'm able to get a good finish and the nib doesn't look unsightly and the ball doesn't look unsightly, and it doesn't look like it's like a lot of porous welding, as you'll see in the coming moments of this video. Once that's done, then I will take and I will use these. Basically, they're like a scratch pad, and then I'll clean up the weld even more and smooth it out before I go to final sanding and polishing. So I'm not going to bore you with showing you all that. I'm just going to do it, and then it's not a very difficult thing for anybody to ever use a handpiece and know how to, you just have to be, it's such a small area, you just have to be very delicate with how you work with these. One thing to note is that I am doing this under microscope, and that's very important because I get to be a lot more accurate. I have a number of microscopes in my shop, including the one on the welder, but I have one here, I have one at my jeweler's bench, and then one at my engraving bench. Because pens are not they're not very big, and there are a lot of micro parts when it comes to pens, microscopes help to get to view areas where you wouldn't normally see them. So this is why I do this under microscope, and I tend to get a much better finish and a much better look out of each nib. One thing I did forget to mention is that I do use a lot of Jeweler's diamond files. I have a big group of them over here, and I'm always looking for better ones. And I use the diamond files a lot to do some shaping on the edges and on the top of the nib. And once I'm done hitting it with the diamond wheel to flatten it out, I come over here and I start going over top to where I can get the nib and the welds flush with the nib metal. And that takes a while, but the results are going to be good. Okay, after the top of the weld is ground down and flush with the rest of the nib, you get an idea of how nice that looks. The weld has been ground down, but there's no missing metal. All the metal that was added, that was excess, was taken away, and we've got a flush surface with the tipping flushed at the top. I always make the tipping to stand proud of this, so then I have something to grind down and to fill in to make it look nice. Next, we'll go to the bottom, and we did do a couple of things on the edge there to get it nice. And at the end, we use some of these hard sanding sticks, and they work really well to get the finish looking a lot better. But that is most of the tipping that you see there. More on the underside than on the top, though. You're seeing it start to come to life here. I'm trying to get as close as I can for you. But you see that as the weld grinds down, we're exposing the ball, but we're not taking the weld all the way down. Basically, we're just tapering the weld down to the metal. Sort of looks like a ski jump. And that adds more weld surface and makes it a much stronger tip than even, I believe, the big boys. It takes longer, it takes a few minutes, but once I'm done, I think you'll see the results are quite pleasing. As you can see, as I go through the different grits and I start taking down my sides to be a more aesthetic looking nib, you can see it starts to taking shape and looking a lot better. Now this is just done with the coarsest of the finishing bits that I have, and I'll keep using them till I get a finer finish. But as you can see the ball and where the weld kind of meets, and it looks really, really good in my opinion. Work continues. You can start seeing the base there, and I'll fill that in and feather that in basically as I keep taking it down and making it more aesthetically pleasing. Here's where we are right now, and I want to show you a couple things that is kind of neat about having that welder. So as you can see, I'm pretty good with my finish of my weld here. As you can see, it's kind of tapered in, and you're looking at a very close up. And there'll be a lot more shaping to this nib and polishing and sanding. But as you can see, that nib, the tipping is welded on pretty good. Over the top, I noticed there was a small fissure on this side. And the old adage that you can take metal away or you can take material away but you can't add it does not hold true in welding. The great thing about welding is if you find a spot where it's got a hole, you could fill it. You can add metal, you can add a lot of metal. So all I have to do now is just take this top down, and it should be flush and with no fissures. All right, as you can see, we have a pretty nice nib, and I was able to get rid of that fissure in there. You can't even tell that I even did it. But it's the great thing about showing people things is that how they can be done and how they can be fixed. on the underside, you see my fingerprints, but you see a pretty smooth weld. And this is going to be a nice nib. Next, I'll take it to my jewel tool and polish it up, and we'll see how it looks. Okay, after the jewel tool, which is a great tool by the way, I'm able to get into all the cracks and crevices and everything and to smooth everything out. But you can see that the weld is pretty decent. They're going to be a little bit more sanding, or, you know, once I slit this nib, but for the most part, this nib is pretty clean. And the tipping is nicely welded. And I'll show you what it looks like on the feed. Okay, here we go. Not too bad. On the feed, it's a nice fit. It's on there pretty snug. It's not choking. It's not too tight. You can take it off with your fingers. Let me get it placed. See? And it can go right back in. But it's a nice fit and finish. And that's what you want. So next we'll slit. Before I put it in the slitter, I'm going to show you something that I do. I measure where I want my blade to land, because you want your slit. I tend to keep my slits about 15 millimeters long, which is about roughly the same size as a Jowo number 6. Pelicans usually have a smaller slit than you'll see in a Jowo or a Bach. I like to have a smaller slit most of the time because it helps with the stiffness of the nib. Now, I will do a longer one if somebody wants a softer nib, but that's all personal preference. But if I just were to leave this mark here and start slitting it, you couldn't see, because the oil that I use to slit these would wear it away, basically, as you know, it starts to cut. So I put a piece of tape here, and that's my border. Okay, I'm holding this by my hand, but let's take a look at these slitters. This is one right here, and you'll get the idea how they work. There's an arm here, and it goes up and down by using this screw feed. Right here, you're going to see where the nib sits, and I'll show you on the other one, but I just wanted to show you what it looked like without a nib on. Here we have the blade, and it runs at 25,000 RPM. Let me show you. It's pretty fast. In the next segment, I'll show you with the nib on it. So these saws were developed for me with the help of my friend Robert Sanchez. He's the owner of Rob Sanchez Pens, and he's an engineer by trade, and he does great work. But you can see the nib on here, and it's kind of a hard machine to explain, but you can see where it sets, and you can see the tape on there, and it's held down by this arm. And what we do is we use a light so we can see it better wherever the blade is going to land. Now, this machine is completely adjustable. I can adjust it side to side or coming forward. So next we'll slit it, and hopefully we go right down the middle. If not, it was all for nothing. Looks like we might have gotten it. There it is. That's pretty dang good for the human eye. I mean, you're talking about we're cutting a 1.25 millimeter ball right in half, and this is right after slitting. I didn't do anything to it. And we've got most of the ball still there, and there you go. You can see it really good there. So I think we're going to be okay. Now with the slit cleaned up, you get a better view of it. And it's almost impossible to get it perfect. I don't have the ability to do that. I mean, again, I'm just doing it with my human eye, but you know, that's pretty well in the middle. And I just cleaned it up with a sanding pad and then run a thin dental diamond file through the middle of there to clean up any of the burrs so you get a clean edge. And the last thing we're going to do now is add our breather hole. On a lot of the nib making videos, you see that the breather hole is already punched before they even slit. Well, a lot of times I think that's a bad idea, because what happens is that you can not get it right down the middle, and it even happens with Joe O's and Box, and everybody who knows nibs knows that. So I always cut it last, and what I do is I use a punch or a scratch awl, and I run it down my slit till I get to the very end, and then I just do one of these, and it gives me a place where I can put my drill. Then I put it in here, so it's just a slit that I cut, that I use for a lot of different reasons on my bench pin here. And I find the hole that I had given with the scratch awl, and that fits perfectly. And using an old style jeweler's drill, that's all it takes. Once again, back in position, and we'll do this real time. I'll hold it, and I just drill. And it's placed perfectly. And we're going to get there in just a second. I think we're down through it. And you'll see it's perfectly placed. And we'll just clean that up, and I'll show you the finished product. All right, here we are. I'd say we did pretty good. Nice clean slit. Look at that breather hole right down the middle. Now next I would go to engraving or heat set this first. But our welds look good. You're never going to get anything perfect when you're doing things by hand, but it doesn't look unsightly. And I want to thank everyone for, being a part of this, because nib making is not the easiest thing to do, and it's hard to teach. And hopefully you guys get something out of this. Periodically, if I have new updates, like on this one, I'll continue to update my videos as long as I'm making. But thank you very much.